Well, hello, everybody. Welcome. Hey, this is the video you need. If you're learning how to factor the difference of squares, or if you just need a little refresher, we're going to run through 5 different levels. These 5 right here, we're going to talk about the basics, which is the how and the why and the stuff that people mess up quite often when they're just learning. And then we're going to run through several different examples till we get to, well, this crazy thing here. And we're going to talk about the traps that lay in wait for students along the way. So you can use the timestamps to navigate. Let's get to it. First thing first, the basics. What is a difference of squares? Well, difference of squares is just 2 square numbers being subtracted. Now, square numbers are any number squared. Like you see the first 7 of them there. 1 squared is 1, 4 squared is 4, 7 squared is 49. Any number squared is a square number. Variables count too. Any variable that has an exponent that's even number is actually a square. Now, that might not make sense. So let me show you. X to the power of 6. Well, 6 is 2 times 3. And because when you raise a power to a power, you can rewrite that 6 as x cubed squared. So x to the power of 6 is a perfect square. X cubed squared. So if you have any exponent that's even, you divide it by 2, raise it to the power of 2, boom, you're done. So, for example, x to the 14th, that is, of course, a perfect square. X to the 7th squared is x to the 14th. So, a difference of squares is any of these things being subtracted. So, it could be 49 minus x squared, or the other way around, x squared minus 49, or 4x to the power of 12 minus 1. You name it. Any combination. All right? Now, let's talk about how you factor a difference of squares. So if you have a square number minus another square number, well, whatever's being squared here and whatever's being squared here, well, you have to figure those out, and then this is your formula. Works really easy, and it could go either way. You could put the negative first, or you could put the negative second. It doesn't really matter. Let's see an example where people kind of mess up, all right? So this is actually the most common mistake. People see this and they forget that a squared minus b squared, well, that describes this, but the formula is a minus b, a plus b. So we're not actually going to use the x squared in 100 like this. This would be a terrible mistake. People mess that up all the time. So the first thing you got to do is you got to slow down. You got to figure out, hey, what squared is x squared? Well, that's x. And what squared is 100? Well, that's 10. Then you can use your formula, right? Because it turns out a is x, b is 10, not x squared in 100. Okay, so now we can just apply it to our formula. X minus 10, x plus 10, boom, you're done. You could have it the other way as well. You could do x plus 10 and x minus 10. Works either way. So let's leave this over here as an example, and then let's talk about why this actually works. So when you're factoring, what you're doing is you're actually unmultiplying something. You're taking something that was perhaps multiplied together to get this expression as a result, and you're breaking it down. So if we take what we factored and multiply it together, we should end up with what we began with. So if you have 2 things like this, those are binomials. The shortcut to multiply those is FOIL. So first, right, outer is plus 10x. Inside would be negative 10x. And the last 2 would make, right, L's for last. Last 2 would make negative 100. So just like that, you see? So the middle 2 terms, well, they cancel each other out. Negative 10 plus positive 10, that's 0. So x squared minus 100. That's how it works. And it works that way because the outside plus the inside, well, they're opposite numbers. They cancel and make 0. Pretty cool. All right, let's move on to the intermediate level. This one, what's tricky about this is actually identifying what are a and b, right? So we're looking for the number that's being squared that goes here, the number that's being squared that goes there, making sure that it's a subtraction, right? Well, what squared is 25? X squared? Well, that would be 5x. And of course, 7 squared is 49. So let's go ahead and use our formula right here. A plus b, a minus b. All you got to do is plug it in just like that, and you're done. It's not too bad at all. I think you can handle this. All right, let's try the difficult one now. All right, 81. X to the power of 6 minus 4y to the power of 10. All right, the tricky thing is we got to figure out what are the values of a and b. Some people say take the square root of these, but I think that's kind of clunky and ugly, and I think it's just easier if you recognize, well, the numbers are pretty easy, right? 9 squared is 81, but what about that 6? Well, that would be x cubed squared, and the 10, well, that'd be 5 times 2. So here, let me show you. This is how it's going to break down. Let me show you why. If we took that square, right, 9 squared is 81, and x cubed raised to the power of 3, well, you multiply those exponents. 3 times 2 is 6. Same thing over here. 2 squared is 4, and y to the 5th squared, well, you multiply those exponents and you get 10. So just take your time with that. That's the trickiest part. Plugging it into the formula, no big deal. Easy and done. And it doesn't matter which one goes first, the negative or the positive. The positive could go second or first. It doesn't matter. All right, now let's try the pro level. Oh boy. This one's kind of ugly. The reason why, this isn't a perfect square, 32x, and neither is 2xy to the 12th. However, there is a common factor we can take out. Do you see what it is? Well, we have an x in both terms, and we also have a 2. So let's go ahead and divide those out and see what we get. All right, so we could take 2 out of both terms, and we'd end up with 16, right? We could take the x out, so that's gone. So we're left with 16 minus y to the power of 12. That is a difference of squares. One square number, 4 squared, minus another square number, y to the power of 6 squared. Boom, we're done. Check that out. So let's go ahead and identify our parts, right? There we go. And then just plug it into the formula. And this is where you can get into a lot of trouble. Check this out. We're not done factoring until it's all the way factored, and our answer still has a difference of squares. Do you see where it is? It's right here, 4 minus y to the power of 6. Dang, if you leave that alone, you got caught in the trap. You're in a little bit of trouble. So let's avoid that. Let's talk about what we can do to fix this. So we still have a difference of squares right here. That's 2 minus y cubed squared. So 2 squared minus y cubed squared. So here you can see a is 2, b is y cubed. So let's go ahead and just factor that part right there in yellow and blue, right? And then make sure we leave the rest of it, with the answer. And boom, we're done. There we go. So what we're saying is 32x minus 2x to the times y to the power of 12 equals this big ugly thing right there. Pros always factor completely. So don't let them catch you short. All right, let's talk about the last one. Man, sometimes factoring difference of squares comes up in weird problems like this. The square root of 50 squared minus 1 over 51. Now you might be tempted to try to simplify this by squaring, subtracting 1, and reducing. Man, you could do it, but it's going to take a long time. But if you notice, this is a difference of squares. Do you see? A is 50, B is 1. So we can factor it just like this, even though they're just two numbers. And yeah, we could square this and then subtract 1. We could do it this way instead. And watch how easy this turns out to be. 50 minus 1 is 49, and 50 plus 1 is 51. And we have a denominator, 51. Those reduce and go away. We're left with the square root of 49, which is, of course, our good old friend number 7. That's pretty cool. Hey, if you enjoyed this, you learned something from it, like, subscribe, share, comment, all the stuff the cool math kids are doing. If you're a teacher, I have a weekly math problem just for fun on my Substack, and I also have all kinds of good stuff on my Teachers Pay Teachers and my website. Links in the description for all of that stuff. Until next time, I hope you have a great day.